Marching onward in Euclidean geometry, let's just knock down all the things that flow from the Euclidean parallel postulate. The whole idea of trigonometry, this idea that we have a right triangle and some angle here, and we want to talk about the sine of that angle or the cosine of that angle. Well, what's all that dependent on? It's dependent on the fact that if I drop a bunch of altitudes, well, a bunch of perpendicular lines, that all of these are right triangles, and that angle is in all four of the triangles, and so the ratio of this to that is the ratio of this to that is the ratio of this to that is the ratio of this to that. We call that ratio tangent theta. The ratio of this to that is the ratio of this to that is the ratio of this to that. That's sine theta. So the whole idea of trigonometry flows from the fact that we have similar triangles. It is strictly Euclidean. There is no trigonometry in the neutral world that works in all versions of the neutral world. Trigonometry takes a stand with respect to the parallel postulate. And in fact, if I can greatly simplify, so let's let this side be little a and this side be little b and this side be little c. Those are just the lengths of those sides. Then if you would consider for the moment the sine of theta squared plus the cosine of theta squared, well, the sine of theta, that's the opposite over hypotenuse. And the cosine of theta, that's the adjacent side over the hypotenuse, and that's a squared plus b squared over c squared. But you and I both know from the Pythagorean theorem that a squared plus b squared is c squared. That's 1. And that's why in high school you learned and memorized sine squared theta plus cosine squared theta is 1. It all flows from things that depend on Euclid's parallel postulate. Just a quick side note here. Oh, wait, too far. Just a quick side note here. For obtuse angles, we define that the sine of theta is the sine of 180 minus theta, and the cosine of theta is the negative of the cosine of 180 minus theta. And we define that the sine of 0 is 0 and the cosine of 0 is 1 because those things seem to make sense. We define them because we don't want to bring in the unit circle, because we don't want to deal with third and fourth quadrants, because in our geometry, there is no angle measure greater than 180. So we can get away with these definitions, and we have reasons why those definitions should be made, but in our geometry, we just need to define that and say, this is how we're going to do it. We don't need a big explanation on why that works. Going to prove the law of sines and the law of cosines in the examples video. Hope this is helpful to you. There's a lot that's just plain Euclidean. Okay.